In this video, we will be covering the basic concepts of atoms, isotopes, and ions. What are atoms? Atoms are basic building blocks of matter that make up almost everything around you. Different types of atoms make up different elements. For example, you know oxygen, carbon, and hydrogen. These are all elements made out of atoms. Oxygen is made purely out of oxygen atoms, while carbon is made purely out of carbon atoms, and hydrogen is made purely out of hydrogen atoms. Let's take a look at the parts of an atom. We have protons that are positively charged, neutrons that carry a neutral charge, and electrons that are negatively charged. Protons are positively charged particles located in the nucleus. The number of protons is the same for all atoms of the same element, and they are equal to the atomic number or the identity of an atom. For example, the carbon atom on the right would have 6 protons. If you change the number of protons and the atomic number changes as well, and you would end up with a different atom of a different element. Neutrons have a neutral charge, and like protons, they are located in the nucleus. If you add up the number of protons and the number of neutrons, you would get the atomic mass. So for example, on the carbon atom, the carbon atom has 6 protons and 6 neutrons, so its atomic mass would equal to 12. Electrons are negatively charged particles. Instead of being located within the nucleus, they are located in orbitals revolving around the nucleus. In atoms, the electrons and protons need to be equal, so the positive and negative charges will cancel each other out and the overall atom will carry a neutral charge. So here we have the periodic table where all the elements are listed. As you can see, the atomic number is listed on the left-hand corner, while the mass and the name of the atom are listed on the bottom. The columns that you see are called groups. So for example, hydrogen would be in the first group, lithium, sodium, and potassium, and so on. And beryllium and magnesium would be in the second group, and so on. So the columns are called groups. Meanwhile, the periods that you see, they're the rows. So hydrogen would be in the first period, and helium would be in the third period. Lithium, beryllium, boron, carbon, and so on will be in the second period. This will come in useful in the future. So we know that protons and electrons need to be equal in an atom, but what about neutrons? Isotopes are atoms with the same number of protons but different number of neutrons. And when the number of neutrons change in an atom, the atomic mass also changes. Let's take a look at some examples. So notice how the number of protons stay the same, so they are all carbon atoms. However, the number of neutrons differ, and therefore on the left hand side we have carbon 12, which has an atomic mass of 12, and in the middle, since we have 7 neutrons, the atomic mass would be 13, and on the right, 8 neutrons create an atomic mass of 14. So these are all isotopes of each other. So in a sense, you can think of isotopes as different versions of the same atom. So let's try some problems on isotopes. Pause the video and see if you can do these questions. How many protons and neutrons are in an atom of calcium-42? Well, we know calcium has an atomic mass of 42, and it has an atomic number of 20. So if we subtract 20 from 42, we would get 22 neutrons. So calcium would have 20 protons and 22 neutrons. And how many protons and neutrons are in an atom of oxygen 18? So again, the atomic mass would be 18, and we subtract 18 minus 8 to get 10. So there are 8 protons and 10 neutrons. So this tells us an important relationship between the atomic number and the mass number and the number of neutrons. If you subtract the atomic number from the mass number, you get the number of neutrons. So when the number of electrons changes, we don't call them atoms anymore. Instead, we call them ions. Ions are created when atoms lose or gain electrons from chemically combining with other atoms to create new compounds. Okay, so if an atom loses electrons, it becomes more positive because there are now more protons than electrons. If an atom gains electrons, it becomes more negative because there are now more electrons than protons. So on the right we have a sodium atom, and a sodium atom has 11 electrons surrounding its nucleus. But if it loses one of those electrons, it now has a positive charge because there are now 11 protons in the nucleus and only 10 electrons surrounding the nucleus. So the sodium ion would have a positive charge. So we have two different types of ions, cations and anions. Cations are ions with a positive charge. They have already lost electrons. So for example, the sodium atom loses an electron and becomes a sodium cation. And anions are ions with a negative charge, so they gained electrons. So for example, chlorine over here had 17 electrons, but when it gained an electron, it became an anion with a charge of -1. Okay, so let's review what we've learned in this video. So we have atoms, which are fundamental parts of all matter and make up all elements. And they're composed of protons, which are positively charged, neutrons, which are neutrally charged, and electrons, which are negatively charged. So protons also equal to the atomic number, and the atomic mass is the number of protons plus the number of neutrons. Isotopes are atoms with the same number of protons but different number of neutrons. So when they give you an isotope, they already gave you the mass, so you subtract the mass from the atomic number to find the number of neutrons. And ions are charged particles from gaining or losing electrons. So we have cations and anions. Cations are positively charged ions because they've lost electrons, and anions are negatively charged ions because they've gained electrons. Thank you for watching, and if you would like more practice questions, there are links available in the description below.